Now we move on to see how to get the antilog of a number. So that means that number is basically the logarithm of some expression which has been already considered previously. So to find the antilog of a certain number, we know that that number will be given to us in the form of some characteristic dot some mantissa, right? So what do we do is, the procedure is exactly opposite to that what we used in finding out the log. If you recollect, while finding out the log, we first write down the characteristic and then we write the mantissa. Here we first consider the mantissa and then consider the characteristic. Okay, so let us first consider the mantissa, which is the set of 4 digits. Now based on these 4 digits, we refer to the Antilog table and get the corresponding entry of 4 digits. Okay, so this is where we have to use the anti-logarithms table. And then once we have found out the 4 digits, the only task remaining is to decide where to put the decimal point in the final answer. Okay, so that we decide based on the value of the characteristic. Okay, or just to put it in different words, we can rewrite the original number in the exponent form itself, and that gives us the answer. Okay, so just to recap, to get the antilog of the given log quantity, first of all we refer to the mantissa part. From that we get the 4 antilog digits using the antilog tables, and then looking at the characteristic we decide where to put the decimal point, or alternatively we write the final answer in the exponent form. Okay, let us solve an example so that this process will be clear. Okay, here is a question. We have to find the antilog of 1.5742 with the base 10. Okay, so if you see, characteristic is 1 and the mantissa is 0.5742. Okay, now if you see the procedure, first of all we have to look at the mantissa, that is 5742, and go to the anti-logarithms table. Now make sure that you are on anti-log table only and not the log table, because that's a very common mistake while doing the sum in the exam. Okay, alright, now the procedure is similar here also, that is we go to the row of 57 in the anti-log table, then we go to the column of 4, that is a third digit. So in the row 57 under column 4, you will observe that the digits mentioned are 3750. Now to this we have to add the mean differences mentioned under the last column, that is column number 2. So in the row of 57 and under the mean difference column of 2, you will find that the digit mentioned is 2, so therefore that gives us 3752 as the sum. Now the remaining part is we have to put the decimal point at the correct place. Now if you observe here, the characteristic is 1, that means log of certain number is having the characteristic as 1. So clearly the number has to lie between 10 raised to 1 and 10 raised to 2, simply because in case of 10 raised to 1 the characteristic would be 1, and in case of 10 raised to 2 the characteristic will be 2. So if our number is 1 point something, then clearly it has to lie between 10 and 10 square. So that means the number must lie between 10 and 100. So if we ask the question, where should we put the decimal point so that the resulting number will be lying between 10 and 100? Clearly we must put the decimal after 7 and the answer will be 37.52. Or the other way of deciding where to put the decimal point is something like this. Let us write the 4 digits obtained at the end of anti-log table process. So we get 3752, and we got, or we know the characteristic as 1. So we can write this number in the exponent form as 3.752 into 10 raised to 1, because we know that the exponent of 10 is nothing but the characteristic, and we must have the decimal digit after the very first non-zero digit. So therefore 3.752 into 10 raised to 1 is clearly equal to 37.52 only. So therefore this is the final answer. So that is the way to find out the antilog. Basically when we say that antilog of say x to the base 10, that means we are actually finding out 10 raised to x, that is the exponent of 10, because we know that antilog is merely the reverse operation of taking the log.